Welcome back to XYZ Architect. Imagine a language universal and timeless, understood by civilizations across the ages. A language that has shaped the world from the pyramids of Egypt to the skyscrapers of today. This is the language of technical drawings. Human drawings are considered a universal language, and they've been around with evidence since 12,000 before Christ. Walls from ancient caves have been inscribed with different drawings that gives clues on how humans documented the way they lived in ancient times. As societies became more civilized, they began to draw how roads, cities, bridges, and different types of architectural buildings have to be built. Therefore, the technical drawing was born, being the most important tool to have in the planning stage of the project. And this fact is valid even in our days. In the year 2130 before Christ, in the city of Lagash, located in the country that was later known as Babylon, an engineer and governor of the city named Gudea worked hard to shape the city. And we have the proof of his work even today at the Louvre Museum in Paris, France, on one of his statues that shows the top plane view of a temple from that era. Several hundreds of years have passed since then, and we arrived in the year 450 before Christ, where Ichthys and Callicrates, aristocrats of the Parthenian from Greece, one of the most beautiful architectural structures that we have even today, started using perspective drawing by using parallel lines in their drawings. There were evidence that in the whole world, different approaches of the technical drawing was used to construct different structures or equipment. But it wasn't until the 14th century that the non-mathematical and the mathematical approach was introduced. Giotto and Duccio, the famous two painters, used both the non-mathematical approach to create perspective drawings by using symmetry, parallel lines, and the technique of foreshortening, while Italian architect Brunelleschi used the mathematical approach. And we have to mention some other key characters in history where the basis of technical drawings as we know them today were set. Characters like Francesca, who used orthogonal projections to create three-view drawings, Leonardo da Vinci, who explained in detail about the perspective drawings, Duter, who published the first book on orthogonal drawings, and William Farish, who introduced the term of isometric drawing. But Gaspard Monge, a French revolutionist who lived from 1746 to 1818, is recognized as the father of descriptive geometry, that is the basis for today's three-dimensional representations on two-dimensional papers. He contributed to the equations of the normal plane, the tangent plane, curves on non-geometrical shapes, and so on. Another significant impact on technical drawings has had the computers. From 1950, when the first computer driver display was used to produce simple pictures. And in 1963, a student from MIT by the name of Ivan Sutherland published his doctoral thesis on interactive computer graphics that paved the way for computer-aided design, known today simply as CAD. More studies were done from 1970 to 1980. Therefore, bitmap graphics were popularized by IBM and Apple, and this led to inexpensive graphics-based applications. Emerging from these studies were softwares like AutoCAD that we know today and VersaCAD that not a lot of people have heard of. These softwares helped and simplified the way a designer creates technical drawings, replacing the old ways where pencils and lines were used to illustrate what the designer's ideas of creation is to a digital way. I really hope this video was fun to watch and that you've learned something new. And if you want to learn how to read technical drawings from zero, then I have a proposal for you. If you join my exclusive membership on Patreon channel or right here on YouTube, I will give you 50% off from my Udemy course How to Read Technical Drawings. Whatever is your choice, get my course or not, take my advice and don't stop learning and improving. See you in the next video.